All right, hey students, it's Mr. Chang coming back at you. Hope you guys are all doing well. This is lesson 4.2, multi-step trig problems with two triangles. These are two right angle triangles. The goal here is to use the three trig ratios, maybe even the Pythagorean theorem if that opportunity is there, to solve unknown sides and angles in two right angle triangles. All right, let's get straight into the steps. And it says here, the steps for problems with two right triangles. You want to start with a triangle with at least two known sides or an angle and a side. And then from there, you're going to apply SOHCAHTOA or the Pythagorean theorem to solve for the unknown or connecting side or angle. And then solve for the unknown or second triangle, whatever is missing in the second triangle. So I want to highlight this part. That's the connecting side or angle. I'm going to use green for that. The connecting side or angle is the key, because if you know where that is, then you can give yourself a game plan and do this with the least amount of steps and minimizing, potential mistakes or just wasting your time and stuff. You want to be efficient with your work too. Let's go. It says here, determine the length of side X to the nearest tenth of a meter. And going through those steps, the first thing you're going to notice is we've got two triangles. They're back to back, and they are truly both 90-degree angle triangles, right? And I know that because this whole thing's 180 degrees. And of course, if half of it's 90, then the other one's 90 as well. Okay, so I'll just put that in just as a little place marker. And looking at both these triangles, you got triangle ABC, and you've also got this triangle BCD. And which one of them actually has two pieces of information there? And it's actually BCD. ABC only has the 25 degrees. So our strategy is to work with this triangle first. And from this triangle, we're going to get the information we can so that we can work with the other triangle and solve for the X we're looking for. That's our goal. Okay, so another thing I want to highlight is our connector, and that is the side that they both share. If we solve for this, notice I'm using green, I can get the other piece of information I need to be able to get X. So here we go. First off, looking at BCD, I'm going to label out my hypotenuse, which is directly across. My adjacent, right? This is my angle. My adjacent is right here. And then my opposite is right here. Okay, and going at it, it looks like I don't really need the opposite. I'm going to take that out. This is going to be a situation where I use, for triangle BCD, right, I'm going to be using the adjacent and the hypotenuse. So that is CA. Okay, so that is cosine of theta is equal to adjacent over the hypotenuse, which means, let's get us some details here. The cosine of 40 is equal to, and we are going to give a letter for the adjacent. And the reason why I'm doing it is because this adjacent won't be the adjacent on the next triangle. So I really want to avoid that situation occurring. In my substitution, I'm going to put an X, okay? And that'll just save us from potential mistakes here. I got a hypotenuse on the bottom, and that is 30. Okay, so in order to solve this problem, what we need to do is we need to multiply both sides by 30. And if you do that, you're going to get these guys to cross out, and you have 30 cos 40, which works out to be 22.98, or I'm going to round that to 23 is equal to X, because, even to the hundredths, that's an 8, changing that tenths to a 9, that's enough to call 23 meters. That's our connector. Okay, that's our connector, which is in green right there. And I know that's 23, so we can come in now and just write that as 23 right here. Okay, now let's talk about the other triangle. That's triangle ABC, because now we're home on the home stretch here. We're going to work this out. If I take out what I wrote for the other triangle and looking at this triangle, I'm going to take a moment and label it out. I got a hypotenuse directly across, and I've got an adjacent, and I've got an opposite right here. It looks like I need the adjacent and the opposite, so I'm going to cross out the hypotenuse. Okay, and adjacent and opposite means TOA. Okay, so let's write that out. Right, and our substitution should look like this. Tan of 25 is equal to the opposite, which is now 23, and the adjacent, which is what we're looking for, is x. Okay, if you remember, we're going to break out the little monkey wrench here and switch these two around, and now we get x is equal to 23 divided by tan 25, and that actually works out to be 49.32365. If you look over here, we are instructed to figure this out to the nearest tenth of a meter. So I'm going to call this x is equal to 49.3 in meters. Okay, that's it. Boom. All right. So again, just use the SOHCAHTOA to figure out the first triangle where we have two pieces of information, and then we can use that that new piece of information, that connector, so we can work out the second triangle right there and get the value we need, which was a highlighted x. Let's keep it going. It says determine the unknown angle to the nearest degree. And this looks like a very interesting situation. I'll tell you the key here is what is connecting these two situations, right? The unknown angle is right there. That's theta. And we've got a couple side lengths, the 19.4, right? The 29.3. We've got this angle measure here of 93.2. But I could tell you the whole thing is 180, isn't it? Because it's a supplementary angle. So if that's the case, I'm going to come in and just label x and y, because really I'm trying to get y. If I can get y, I can tell you what theta is, right? The real game plan here is I can tell you that theta is equal to 180 degrees, subtract the 90, subtract whatever y is, because the angle sum of any triangle is 180 degrees. So if I can figure out y, I have the 90. We'll subtract them both from the 180, and we have theta. Okay? Or theta is, just to simplify it, is equal to 90 subtract y. Okay. So in order to do this, then, we need to figure out x. Okay? So let's get to triangle EFG. From triangle EFG, which is where we're working at first, if we were to label it out using this x as our kind of working point, we've got hypotenuse, we've got an adjacent right here, and then we got an opposite here, and I could tell you, don't need it. And so we're going to use the adjacent and the opposite, which is ca, and I'm going to write cosine of theta is equal to the adjacent value over the hypotenuse. And so that is cosine of x is equal to the adjacent, which is 19.4, over the hypotenuse, which is 29.3. Okay, and here, remember, when we're trying to find an actual angle, we're going to have to do the inverse cos. So x is equal to cos inverse of this 19.4 divided by 29.3. Do that in one shot on your calculator, and you're going to get 48.54, right? And x is equal to 48.54. And you know, we are talking about an angle. However, with this angle, I do not want to round it particularly, because if I round it, it's going to shift everything else around, right? This is not a final answer. It is an answer that I'm going to be using so I can do the rest here. So let's talk about GHI, triangle GHI, because triangle GHI is the one with my theta in there, right? So in triangle GHI, I can now say, I can now actually give you y. So let's do y. y is equal to 180 degrees, subtract the 93.2, and also you are subtracting what x is, which is 48.54. And I can tell you that y is equal to 38.26 degrees as an angle measure. Okay, and let's finally bring it home and let's talk about theta. Then is equal to 90 subtract y. So theta is equal to 90 subtract 38.26. And we get 51.74. And just double check, we got to round to the nearest degree. I'm going to have to call this theta is equal to 52 degrees. Okay. All right. Managing okay for time. We've got number 3 here. It says find the unknown quantity to the nearest degree. And again, I want you to look for the triangle with 2 pieces of evidence, right? Because that one will give you the connector, and you're going to use the connector and another piece of evidence to get what you need on the final one. So here we go. This is our goal, the theta right there. And you can see the bottom triangle BDC has an angle and a side. That's the one we're going to use to start off with so that we can create the connector, which is this BC side right here. Okay, once we got that, we'll use it with the 18.6 to figure out theta. Let's go. Starting with the triangle BCD. I know I have this angle. I know I have this side there. Let's label it. This is my hypotenuse right here. This is my adjacent right here. And this is my opposite right here. I need the opposite. That's the 12.8. I'm trying to figure out the green line, the hypotenuse. So I am going to take out the adjacent. And if I write this out, using the O and the H, that is so opposite over hypotenuse. Subbing in, sine is 52.3, sine times 52.3. The opposite is 12.8, and the hypotenuse value is, we don't know. And we got to plug in a variable. I'm going to plug in an x here, okay, to represent it. I don't want to write hypotenuse because in the second triangle, it is not the hypotenuse. Okay, so let's use the x. Let's bring in a monkey wrench so we can do a little sub. And x is equal to 12.8 over sine 52.3. X turns out to be 16.18. Okay, and I'm going to call it 16.18. I know I could round it more, but leaving it to the hundredths is probably a good idea because I need to use that information to carry on and figure out the other part. All right, so let's take out what I wrote on the first triangle, and let's talk about that new triangle here, right here. If we were to label out the new triangle, I have my theta there, I have my hypotenuse right here, right? And I've got my adjacent to my angle right here. Then that means this is my opposite, okay? And you can tell that we need to use this x that we just have. And we need to use a hypotenuse because that's 18.6. We don't need to use the adjacent, so we're going to take that out. So it's O and H. So it looks like we're back at using so. And let's do that on the side right here. Okay. Here we go. Triangle ABC is the one we're working at, and we've got so let's do it. Sine of theta is equal to opposite over the hypotenuse. And so sine of theta, which we are trying to find, is equal to opposite, which is 16.18. And the hypotenuse, which is 18.6. And I'm going to do inverse sine. So you always do that when you're trying to figure out an angle, right? Inverse of whatever your trig function is. 18.6 here. And we can get, let's do that theta better. Sine inverse 16.18 divided by 18.6. Then you get something like 60.44614, and we're going to round that just to 60 degrees because we need a nearest degree situation, right? There's our answer, and we're home. Good. Let's see what I got for you. Here's a treat. It says a drone flying 17 feet captures two people standing on its left and right side. Person A captured at an angle of depression of 75 degrees, and person B is at an angle of depression of 81 degrees. Are the two people standing safely apart? So you can see I took the time to draw out the drone and person A and person B, and I think it looks pretty cute. I'm trying to change the way my people look because these cutesy figures are actually more fun to draw, more fun to look at. And also the drone was not easy to draw. It's actually, it's a weird shape. But we got an angle of depression on both of these, and the drone's looking down on person A at 75 degrees. Right, let's mark these details here. Person A is captured at an angle of depression of 75 degrees, and person B is angled at 81 degrees going down. So let's take a moment and let's mark out the angle of depression. You see, if that's a horizontal, the angle of depression comes down. For person A, that's 70 degrees, right? And for person B, that's right here, this is 81 degrees. What that actually means is, remember when it's angle of depression, the angle's on the outside and we have to put it in, okay? So let's put in some details we now have. One is we got a straight line coming down there. I'll put the, right? And that means this part right here is 81 degrees. And that means this part right here is 75 degrees. Okay, and really the question is saying, are the two people standing safely apart? And this is definitely a social distancing question. Are they standing safely apart? Okay, am I missing anything? Yep, I did mention that it is 17 feet high. Okay, that's a very typical height for where a drone might fly. This is 17. Right here, 17 feet high. Okay, at this current point, I'm going to figure out what the game plan is, because if we're trying to figure out how far they're apart, I'm going to use the letter D here, because that's their distance. But really, what I'm trying to figure out is the distance of person A and the person B here, because I can tell you on the side here, D is equal to A plus B, right? Or their distance. Let me write that better. The distance apart is equal to A plus B. Okay, so let's work with these two situations. I'm going to get rid of my angle depressions now. That's no longer needed. And let's talk about person A. Okay, person A. If we look at person A and I label out the details, I am talking about a hypotenuse right here. I'm also talking about an adjacent right here and an opposite right here. And it looks like I'm going to be using not the hypotenuse. I need the adjacent and the opposite. Adjacent and opposite, that's TOA. Let's do that. Opposite over the adjacent. Notice how I write the formula every time. Taking these baby steps really makes it so that I don't make mistakes, or these silly mistakes where I, for instance, switch up the O and the A and stuff. Tan of 75 is equal to my opposite, which is 17, and my adjacent, which is the lowercase a. Use a monkey wrench and do the little switch. and come back and say A is equal to 17 divided by tan 75, and get A, that distance is 17 divided by tan 75. Well, 4.55. And actually, there's another 5 after it. I'm going to change this to 4.56 feet. 4.56. As it is, they're a little too close together. You know, I'm only saying that because I think we all know that two people need to be 6 feet apart. And 4.56 is a little too close. Don't worry, we can figure out what B is. So let's talk about person B. Person B. Person B, if we work on their triangle, right there, I've got some details again. Person B has a hypotenuse, an adjacent right here, and an opposite right here. We're going to use adjacent and opposite because this hypotenuse isn't giving us anything to gain. Okay, so adjacent and opposite is in play, and we are now talking about TOA again. So tan theta is equal to opposite over adjacent. And I'm going to fast forward. All right, well, there I am. So the distance of lowercase letter b is 2.69 feet. And A is 4.56 feet. So we still need to figure out distance, which is A plus B, right? That part down on the bottom, right? Our green connector was here for sure, right? But we still need to figure out this distance right there, because that is where the answer lies. So let's do it. D is equal to A plus B. D is equal to 4.56 plus 2.69, and D turns out to be equal to 7.25 feet. Therefore, at 7.25 feet, person A and B are at a safe distance apart. All right. Answer found. Boom, boom. At this point, you guys can try a few questions. I gave you 5 questions right here on multi-step trig problems. You can find that as the next worksheet following the video. Thank you very much for your time, guys. Have a great week.